Hi everyone, let's take a look at number 24 on page 420. The magnitude of a scalar projection of 1m0 on 221 is 4. Determine the value of m. Now before we start, you want to go back and think about the formula. So what is the formula for the scalar projection of A on B? Let's draw a diagram. Again, there's a difference between a scalar projection of A on B, or vector A on vector B, versus vector B on vector A. So if I start with a diagram, I'm going to draw two vectors for you, which would look something like this. Now, if this is going to be vector A, and this is vector B, and this yellow part, this length, this magnitude, is the scalar projection. Now notice this angle is going to be 90 degrees. So this yellow part that I'm highlighting for you, that's going to be the scalar projection of A on B, and you can write down the following. So in math, you write down projection. A on B means vector A goes there, subscript vector B. You put the absolute value sign to stand for the magnitude. Now this equals to, in general, the vector A dotted into vector B divided by the magnitude of vector B. Now, in this example, notice there are two cases because they're not just saying find a scalar projection. They're saying specifically the magnitude of the scalar projection. What that means is, if you think about this, it's going to be the scalar projection of 1m0 onto 221. So if I apply this formula, A dot B divided by the magnitude of B in this case, we're thinking about 1 m and 0 dotted into 2, 2, 1 divided by the magnitude of 221, which is basically the square root of the sum of the squares. Now be mindful, this equals to 4, but here's the key. It's asking for the magnitude of the scalar projection. So if you think there's one case, you're partially right. So it's not mathematically incorrect. They can find one value of m, but I'm letting you know, just by inspection, I can tell there are two cases. So the absolute value sign that I'm putting here comes from the fact that we're thinking about the magnitude of the scalar projection. Now, how do we do this? If you think about the dot product, 1 times 2 is going to be 2, m times 2 is going to be 2m, and 0 times 1 is going to be 0. If you look at the denominator, the square root of 2 squared plus 2 squared plus 1 squared is going to be 4 plus 4 plus 1, which is the same as 9, and this equals to 4. Now, if you look at this carefully, I can look at the top and say the absolute value, or the magnitude of 2 plus 2m, let's try this again, divided by 3 equals to 4. We know 3 is positive, so there's no need to put the absolute sign around this. And again, let's zoom in for you. This is the optical illusion. When I zoom in, it'll give you the impression that this is very easy. It is simple, but I won't say it's easy. Now, if you look at the left-hand side, that is the magnitude, right, or the absolute value of 2 plus 2m. If you cross multiply, 3 times 4 is going to be 12. Now, this is a lesson that is kind of prior to calculus and vectors. So I'm going to draw a line in the middle, divide this into two different columns. In the first column, you put round brackets around 2 plus 2m, which equals to 12. That is called the positive case, or case number 1. If you look at the second case, I put the negative sign in front of the brackets, 2 plus 2m, which equals to 12. Now, I go back, and in the first case, if I solve for this, 2 plus 2m equals to 12. The opposite of adding 2 is to subtract 2. 12 minus 2 is going to be 10. So m equals to 5. Now likewise, in the second column, I can expand this first. This would give you negative 2 minus 2m, which equals to 12. Again, the opposite of subtracting 2 is to add 2. 12 plus 2 is going to be 14. Again, the opposite of multiplying by negative 2 is to divide by negative 2. 14 divided by negative 2 is negative 7. I hope this makes sense.